My name is Shanil Virani. Shanil pronounced exactly like the perfume, just spelled differently. I'm an astronomer. So what does that mean? And really, that's what we're going to start talking about. We use these words, chemistry, biology, physics, astronomy, and sometimes we know what they mean. Sometimes we don't. Sometimes we know who these people are that get to do these fun activities, and sometimes we don't. And sometimes we think we can't do it. And really, that's what we want to talk about. Who's a scientist? Who gets to do this kind of fun activity? And what does science mean? And so the first thing, as both Ali Khan and Soraya mentioned, we're going to be using Slido. So on the left-hand side of your screen, you can see there's a funny little picture. And if mom and dad is around and they have their smartphone, all they need to do is use their camera on their phone, and that'll go directly to the website. And you'll see there's already questions coming in from the more than 100 people, I think, that are online now. And so at any point, feel free to go and ask your questions there. We'll have ample time towards the end and even in the middle to answer some of your questions. So the first thing, of course, is, as I said, we're going to use this website, Slido. So if you have a phone, great. If not, you can just use that hashtag MXScientist at slido.com. And so we're going to do that now. So if you can get mom or dad and have them use their phone and go to the website, what we're going to do is I'm going to ask you a question. I want to hear what you think. And so let's open that up. And let me get my app open here that I need to use. So here are some of the questions that have already started coming in. So you can see there's some questions coming in and people are voting up on it. So there's one question about why is there air in the Earth's atmosphere? 4 people want to hear that answer, hear the answer to that question. So that's how you can vote questions that you want to hear. So that's wonderful. So let's do this first one. And here's a question I have for you. Are you a scientist? Now that means you might know what that word is. You might know what they do. And if you don't know, that's a great answer. In science, I don't know is a great answer to a question. So go ahead and vote. Look like neck and neck, almost equal numbers between yes and maybe. Only a small number say no, but that's interesting. So we'll keep going. But half of the group so far looks like they've voted. We'll give you time. Ooh, now it's pretty much even. All right, so maybe another 30 seconds to get your last minute answer in. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Ooh. Okay. Now, so that's one question, and we'll come back to that because let's go to another question. And here, what I want you to do is with your sheet of paper, let's open this question. I want you to describe how a scientist looks like. So you can use words. On your sheet of paper, I'd like you to draw your picture. So on Slido, use words, and so you can see there's already one example. Somebody said nerdy, and that's certainly true, and maybe we'll talk about it. But what are some other words, some other adjectives, some other describing words that come to mind? You hear the word science, scientist, what's the image that comes to your mind? So here on Slido, write your words, and then on a sheet of paper or in your MX, Mission X diary, your journal, start drawing a picture. I want to see what your picture looks like of what a scientist is. And as you watch the screen, you can see words that are entered by your colleagues, by the rest of your team. If somebody says the same word, then that word gets bigger in the screen. So you can see the words like smart, human, are coming up often, so that word is bigger than the other words. You see white coat is probably the third most common phrase, and so that's getting big. And now intelligence popping up. But you can see all this diversity, this huge range of ways that you come to describe a scientist. Okay, so now we've got this great picture of words that are telling us something. What I want you to do now, if you already answered, ready to put in your words into the app, draw your picture. I'm going to give you a minute, maybe 2 minutes, because I know that can be a long time. So what I want you to do is grab a pen or a pencil, a sheet of paper, or use your Mission X diary, your journal, and I want you to draw your scientist now. You've described what that person looks like to me. Now I want to see your picture. So just draw a picture. I was never the most artistic person when I was your age. So my scientist, my person was always a stick figure, whether, however I wanted to draw it. So you can go ahead and draw a stick figure if you want, but then let me see what that person looks like to you. So go ahead and draw it, and I'll put a timer on for 60 seconds, and then we can talk about the picture that comes out.
Ariane, would you like to share your picture with us?
I drew a picture of a scientist holding up some things where there's some chemicals inside.
Some chemicals inside? Okay, wonderful. Thank you. Who else wants to share their picture?
Hello?
Hi.
Hi.
So what did you draw, Anisha?
Face so far. I made the only top of the body of it.
Okay.
So far.
Can you describe your picture? So it looks like, is that person has glasses?
Yes, scientists always have, they always do research about it. So they have, most of the times they wear goggles and that kind of stuff, and they have their own lab coat. So they wear a lab coat, and then they wear goggles to do some, and their hair is most of the times messy because they do so much science work that sometimes some things get exploded on their hair and that kind of stuff. So I made it into my drawing like that.
Very creative, very cool. Excellent.
Thank you.
Some goggles.
Some goggles?
A bottle of chemicals. A
bottle of chemicals?
And then I'm still working on the details.
Okay. Is it a boy or a girl?
It's a girl.
It's a girl. Okay.
So I'm not really finished making it, but basically, it has a picture of my mummy, who is a bit of a scientist.
Your mummy's a scientist, is she? What does she do?
Well, quite a bit of science work, but I didn't really quite finish it. I was just on the arm, and then I couldn't finish it.
Oh, but I love it. So your scientist is a girl. You've drawn a girl, right?
Yeah.
And she's brown, just like you are.
Well, I have quite a light brown skin. My mummy has quite a dark skin.
Right. So scientists can be brown too. Is that what you're saying? Is that what you're saying?
Yeah. And
yeah.
They can have light skin like me, or dark skin like my mummy, or even darker skin.
That's exactly true. And they can have short hair like me, and they can have long, beautiful hair like you.
Yeah.
Right. All right. How about one more?
Well, I'm not really artistic either, but I just really this really simple picture of a scientist. It has goggles, of course, for safety, and a big lab coat. It also has this big giant boots for some reason. That's what I thought of a scientist when it came in my head. And it has short hair.
And has short hair?
Yes.
And is it a boy or a girl?
It's a boy.
It's a boy. But girls can be scientists too, can't they?
Yeah.
Are you a scientist?
Depends.
Depends. What does it depend on, do you think?
Well, I'm too young to have a job, of course.
Mm-hmm.
But like school or something, when we do science, we turn into like mini scientists.
So say that last part again.
Like when we go to school, we turn into mini scientists.
When you go to school, you turn into mini scientists. Now, what does that mean? What happens when you go to school that makes you think you turn into mini scientists? What is it that you're doing at school that?
Well, in my school, we have like safety goggles and a lab coat, and we put that on when we learn science. So it makes us feel like scientists, or like at least mini ones.
Mm-hmm. But do you think you only do science at school, or can you do science away from school when you're at
You can
home?
do science away from school as well. Like at home, you can just make
Mhm.
a mini volcano explosion, or just answer some science questions that you have in your head.
Right. So this is all starting to, we're starting to see a picture. Let's go to our polls. And, we were having, in the questions we were getting back, in the describing words, we had pictures like crazy hair, we had lab coat, we had beakers, right? Test tubes. Maybe they had glasses, they had pencils and pens in their pockets, all kinds of things. And so what I want to do, let's see if this will work now, right? So this is the thing we just did. And for mom and dad, for those of you that I did get to see the picture, even if we did call on you, if you want to take a picture, with your phone, take a picture of your image, and then with mom or dad to share it with us on social media, you can use these hashtags, Mission X20, Space Camp 2020, and the text in blue at Shanil V. That's how you can find me on social media. I would love to see your photos, your images, and what you describe. I want to show you what other kids have done when we ask them that same question. So this is a picture. This was a young girl. Her name was Amy. And Amy lives just outside of Chicago in the United States. So Chicago, of course, is a big city in the US. And in Chicago, just outside of Chicago, in fact, is a huge particle accelerator. Not as big as the one that's in Europe that you might have heard of, something called the Large Hadron Collider that's underneath Geneva in Switzerland. There's one in the United States called Fermilab. And they do particle acceleration, particle work there, looking at the building blocks of matter. And so they asked some kids in 3rd, 4th, 5th grade, so just like you. And this is what Amy said. She said, I think of a scientist as very dedicated to his work. He is kind of crazy, talking always quickly. He constantly is getting new ideas. He's always asking questions that can be annoying. He listens to others' ideas and questions them. And if you look at the picture, maybe that's similar to your photo, right? So you can see Amy's a little girl, is a young girl, but she's drawn a guy, glasses, bald. He's got his lab coat, and looks like there's some chemicals coming up. So then she got to meet a scientist. She got to go to the lab, and she got to meet these people who get to do science, whatever that is. We haven't talked about what science is yet, but whatever she thinks science is, this is what she said afterwards. Now, let's see, there we go. So this is before on the left, and then after is after going to the lab. So you can see in the pictures, she drew a boy, and then after getting to meet scientists and going to the lab, she drew a girl. And look what she wrote now. I know scientists are just normal people with a not so normal job. Scientists lead a normal life outside of being a scientist. They are interested in dancing, pottery, jogging, and even racquetball. Being a scientist is just another job which can be much more exciting. Sometimes we think of science and people who get to do science as not being me or you, that they're somehow different from me and you. And Amy is suggesting, well, maybe that's not true. Maybe scientists are exactly me and you, but maybe there's just one thing or a couple of things that may be different. Let's see what other kids said. So this is Andrea's picture, again, before she got to go to the lab. And you can see her photo, her image. And so there must be something about bald science teachers. They all seem to be bald. But here's her picture. Not so crazy hair, bald, glasses. But again, you got the lab coat, and you get that beakers and test tubes. You get the chemistry part of science. And Andrea wrote, you can see them as a mad scientist with hair standing straight up and a mean, wicked laugh. I see them with rubber gloves and safety goggles on. I see them in a chemistry lab surrounded by beakers, graduated cylinders, and tables filled with experimental materials. So all kinds of different pictures that come to mind, images that come to mind in her description. But you see this mad scientist, and that's something that you guys were also showing examples of, the crazy hair. One of you said, maybe not so friendly, maybe not able to talk to other people. They're just kind of weird. Well, that's what Andrea's drawn. And then this is what she drew afterwards. Now, here's something that I found interesting. So Andrea afterwards still drew a guy, even though she's a girl, but now his complexion has changed. The scientist has gone from being white to maybe being more darker, maybe more brown, maybe like her. Maybe she's seeing herself in that. Here's what she wrote now after meeting a scientist. Scientists love their jobs. They wake up in the morning and are excited to come to work. When you are a scientist, you come to work ready to explore and learn new things. Things that may change the world someday. Maybe not today, maybe not tomorrow, but may change the world someday. So Andrea now is starting to even tell us what science is and what scientists do. She's saying, you come to work ready to explore and learn new things. Do you guys get to explore and learn new things as part of your everyday life? Yeah, of course you do. Yeah, see, so a lot of thumbs up, right? So if you're going to use a definition, or if we're going to describe a scientist as just somebody who likes to explore and learn new things, I think that tells us, maybe that's suggesting, that you are a scientist. It doesn't require somebody with fancy degrees or having gone somewhere fancy, as long as you're curious. Let's do one more. Angela. So I love Angela's picture because you can see how detailed her illustration is. So she drew a woman. She's got a lab coat on. She's not bald. She's got curly hair. She's got glasses. She's smiling. But if you look in the background, looks like there's a fish tank. So not beakers and test tubes, but a fish tank. And she writes, scientists have a strong impact on our world and my life. There are so many different kinds of scientists, and they have many different personalities, but they all have one thing in common, a love for science and discovery. Scientist Judy is wearing her white lab coat. She's a very simple person, simple clothes, simple house, simple personality. Okay. And then here's what she said afterwards. I think everyone has a little bit of science love in them. They wonder about processes in their life, processes in their body. A scientist is a male or a female that enjoys learning about the earth and its contents. And I just think that's such a perfect way to describe science, right? We started off talking about this conversation about what science, what does it mean, what does it look like to the people who are doing it. And here Angela is now giving us a definition. And her definition is a person, male or female, that just enjoys learning about stuff. And the stuff could be what makes her body work. The stuff could be what makes the earth work. The stuff could be what makes the universe work. As you know, the last 4 or 5 months have been very complicated and difficult for people around the world. And of course, how we're going to get through this and how we're going to be able to get back to normal is science, right? Science is going to be able to find us a vaccine for this virus that threatens a lot of people. And so she's right. And what others have said that you heard before too, that science has a way of changing our life. And when you think about it, think about what we're doing right now. You, me, everyone else, we're scattered all over our planet. But because of the technology that science allows, we're talking to our tablets, our phones, or me into my computer, and you and I are having a conversation, and we're not limited to just being able to talk to somebody next to you. I'm having conversations with people across the Atlantic Ocean, in England, And I know there are others from other parts of the world too. And so this is amazing. Because of what we know, because of what we figured out about the natural world and how things work, we can now have these kinds of conversations that we couldn't have even 25 years ago. When your mom and dad were your age, this wasn't possible. So think how far we've come, right? It's just amazing. Oh, looks like I had one more. Okay, so Amanda, this is her photo, her picture. A scientist is in the Guinness Book of World Records. I see a scientist winning on Who Wants to Be a Millionaire. So I think this is the reason why I included this picture, is that, so here Amanda is saying, I see a scientist winning on Who Wants to Be a Millionaire. Now this is an old TV show. Some of you might know of it. Some of you have never heard of it, and that's fine. Just think of it as like a trivia show, or kind of like Jeopardy, a TV show you may have seen or may not have seen. It's one of these TV shows where they ask you questions, and depending on your ability to answer them, you might win a lot of money. In this case, $1 million. So here, what Amanda is reaching for and is trying to share is that a scientist may have a lot of facts, may know a lot of facts, may know a lot of information about something. And in this particular case, they can use the information they know to win money. All right, that's fair. Then here's what she drew afterwards. Anyone can be a scientist. I saw people walking around in sweatshirts and jeans. Who knows? Maybe I can be a scientist. Do you think you can be a scientist? If the only thing you need to be a scientist is somebody who likes to ask questions, then you're a scientist. If a scientist is somebody who wants to learn new things, and you like to learn new things, you're a scientist. If a scientist is somebody who's curious about the world around them, and you're curious, then you're a scientist too, aren't you? So science, we've used this word, and it's come up. Science has so many different aspects to it. So here are some pictures that you can often use with science. The test tubes and the beakers, the chemistry sets that we often see. You all know that. I'm not going to touch on it. Whenever people think of the word science, chemistry is often what comes to mind. But science is so much more than just chemistry. You can see there's a picture of a microscope. And a microscope allows us to see things we can't see with our eyes. So we can look at things much smaller than what our eyes can see, and we can learn what may be in things that we can't see with our eyes. So if you had an opportunity, maybe you've gone to a pond, and maybe when you were little, you took some water from that pond. And if you had a microscope at home, you could put some of that pond water under a microscope, and you'll find that that pond water is not empty. There are things in it. There are things floating in it. And they could be microbial, simple bacteria, parameciums, amoebas. Maybe these are words that you might have heard your science teacher say. And these are small little creatures that we can't see with our eye, but under a microscope, we can see them and we can learn about them. You see a fingerprint. Now that fingerprint is not your fingerprint, it's not mine, but it's somebody's. And by looking at that fingerprint, that uniquely tells us who they are. You see rockets, and of course, you guys are in a space camp that's going to be the next generation astronauts, and that's what you're all excited about. And certainly that's a part of science. And then you see a picture on the far right where you've got the structure of atom. And that's probably one of the deeper questions that science asks is, what are we made of? And you might think that that's a science fiction, something we can't answer, but science now, we have a very good idea. We're made out of things called atoms and molecules, and we breathe this in, we expel carbon dioxide, and even though these are things we can't see, we know that they're there. And so finding out what stuff is made up of is a really big part of science. So these are all different ideas. So what is science? So there's a couple of things that have come up, learning about the world and the cosmos around us. So learning is definitely a key thing. So this comes by watching, listening, measuring. The things you guys have already been doing this afternoon, right? I asked you to describe a scientist, you wrote words. I asked you to draw a scientist, you drew a picture. In science, when we're starting to figure things out, That means we're collecting data. And it's just a fancy word for saying we're collecting information. So we watch, we listen, we measure. We need to write down what we found out because we don't want to forget it. So we put it in our journals. You guys as young engineers and scientists, as part of Mission X, are doing that. And then maybe we start finding out patterns. And we saw that in the pictures that you drew. We saw that in the pictures the young kids drew outside of Chicago. So now we're coming up with trying to explain these patterns. And in science, trying to explain a pattern has a fancy word that is oftentimes misused. And the word is hypothesis. And even though I know I can't hear you and you know I can't hear you, I want you to say that word for me. Can you say it? Hypothesis. It's a long word, right? Hypothesis. And in science, that word has a very precise, has a very specific meaning. And we'll come to that. But a key part of whatever science is, whatever this thing is that we test our explanation. It's not just enough to figure out, oh, there's a pattern here to our answers. If we've got the right explanation, then we can test elements of it to see if our explanation is right. And in testing it, sometimes we find that our explanation is missing a couple of things. Or maybe there are other aspects of it that we didn't account for. So we need to modify. We need to go back and fill in some more details. And sometimes you might have heard of this cycle. It's called the scientific method. And I know it may seem a little boring and dry, but this is what you guys have been doing literally since the day you were born. Since the day you were born to today, right? You're exploring the world around you. You're figuring out things. You've already figured out that if the stove is on, I'm not going to touch my hand on it. Why? Because you probably asked that question a few years ago and you put your hand on the stove and you got burned. And you quickly realized, I'm not going to do that because I don't want to get hurt. And if I touch a hot stove, I'm going to be hurt, right? But that's the sense of exploring, the sense of wonderment. Maybe that's a critical part of science. So science allows us to look at the world around us. And all we want to answer, really, all science wants to answer is, why is the world the way it is and not some other way? These are questions you guys have every day. Why is the sky blue on a clear day? Why is it blue? Why isn't it some other color? Where's the blue coming from? Oftentimes, you'll say, well, the blue is coming. If I look at the Earth from space, I see the blue. Oh, the blue is the ocean. But if you've been to the ocean, you know the water isn't blue. Water doesn't have a color. When you go and get a glass of water from the sink, it's transparent. You can see through it. So when we're looking at Earth from space, the blue isn't from ocean. It's reflecting the atmosphere. Now, maybe that's a riddle, a puzzle you've already figured out, but you're asking these questions, you want to figure out why things are the way they are. So I was trying to figure out, how am I going to answer this? And here's a good way. So rather than thinking of science as a recipe to follow, I think a good way to think of it is science is a way to figure out how things work. So when I go back and ask you, are you a scientist? Maybe that's what you should be measuring yourself against. Am I curious to figure out why things are the way they are? And if you answer yes, I'm curious to know why things are the way they are, then you're a scientist. And you might think, well, okay, I'm not an astronomer, somebody who studies the stars and the galaxies and the cosmos. Okay, I'm not somebody that does chemistry. Okay, but maybe you want to be a medical doctor. Maybe you want to be a dentist. Maybe you want to figure out what are some medicines that I could take to help if I'm sick. It's the same process. It's the same idea. It's a way to figure things out. We need to be careful, and I'm going to go through this quickly, and that is because we use these words, theory and hypothesis, and as I said, in science, they have very strict, very specific definitions. There's a lot of words on the slide, and I don't expect you to read it and to memorize it all, but just remember that when we say the word theory in science, it's not just any old idea for any old thing. In science, the word theory is an explanation that's supported by evidence, supported by the data you collect. And it makes these predictions that you, me, somebody else around the world can go and do what you did and came to the same conclusions you did. So in science, the word theory is a very strong word. It's not just any old idea. In fact, it's the opposite. It's an idea that's supported by overwhelming evidence and has been tested. So I'm going to just read this quote to you. It says, scientists most often use the word fact to describe an observation. Scientists can also use the word fact to mean something that has been tested or observed so many times that there is no longer any compelling reason to keep testing or looking for examples. The occurrence of evolution in this sense is fact. I took this boring paragraph from one of these Science Academy reports. As you might imagine, trying to figure out how we got to where we are, how we got to be humans versus cats and dogs. This idea is a big part of science. It's our story of how we got here. And there's a very convenient picture idea. It's called evolution, of how life arose and the diversity of life we see. And it's supported by this evidence. And that's what this paragraph is saying, is that sometimes we have a model and the evidence is so strong and so consistent, it becomes a fact. Evolution, you might hear the theory of evolution, but for a lot of biologists, it's the basis of their subject. They start from the idea that life originates and evolves due to this process, and they go from there. Okay, so let's summarize what we figured out so far, right? A scientist. A scientist can be anyone. And you said that, you drew that. Some of you are starting to realize that now, maybe from some of the photos, the illustrations the kids drew, right? And we're recognizing that they can be male or female. Science isn't something just done by boys. Sometimes you might hear that. If you're a young girl, maybe somebody has told you that, oh, only boys do science. That's not true. And usually it means that they're jealous if they're telling you that, because that means you have a lot of really cool and neat ideas that maybe they don't, right? So scientist is anyone that is curious, and that can be a boy or a girl. They can be from any part of the world. They can be from the UK, they can be from the United States, they can be from Canada, where I am, they can be from other countries all over. It doesn't matter what religion or the color of their skin are. It doesn't matter if they're rich or poor, or how old they are, or how young they are. As long as you're curious, as long as you want to figure out why are things as they are and not otherwise, you're a scientist. So the only thing that science demands is that you're curious. And so as you go through the summer program of becoming an astronaut, when you think about going to the moon, going to Mars, and your generation, kids your age around the world, that's your future. We're going to live in a world after coronavirus is long gone, where your generation is going to be living on more than one world at the same time. Can you imagine that? For our entire human history, we've had humans on planet Earth. Now, where they've lived on Earth has changed with time. We now occupy all the 7 continents, well, 6 of the continents at least, and we do research on the 7th. But we now have humans that live everywhere on Earth. In your generation, we might have humans living on the moon and Mars. And so the last thing I wanted to show you is this beautiful saying. When I was your age, I started watching a lot of science shows on TV. You probably watch them on YouTube now. And there was a scientist, somebody like me, that was doing science, but he was talking about what science is. What does it mean to him? His name was Carl Sagan, and you can look him up afterwards if you want. He was an American astronomer. So He lived in the United States, and he was interested in understanding the stars above us, the planets in our solar system. And he wrote this, which I've always loved. The discovery that there is order in the universe, that there are laws of nature, is the foundation on which science builds today. Science is a collective enterprise that embraces many cultures and spans the generation. Its only sacred truth is that there are no sacred truths. Now, the words in red, I've made red. Of course, he didn't choose that color, because that to me was a critical part. So there's a lot of words in there. What does that mean? Science is a collective enterprise. All he's saying there is that science is done by me and you and everyone around us. It's done by humans. And as long as we have people doing this question, or asking this question and trying to figure things out, that's all science is. And cultures, all kinds of cultures, all through time have done it. The sentence in red, it's only sacred truth. It means we question everything. There isn't a question we can't ask that at least we can't go out to try and answer. There are going to be some questions that we don't know the answer to. And these are questions you've already started, may have already started asking. Why do we dream? In my dream, when things happen, why does that happen? Right? And we have ideas. And so people who study that might tell you what's going on. But there's a lot of things we don't know what the answers to, but we can ask the question. It was this next part that I loved. It says, all assumptions must be critically examined. It means any things that we assume, we have to go and look at that. Arguments from authority are worthless. And that's a really important sentence. It's only 5 words, but it may not convey to you what he's saying here. It means that just because somebody said something doesn't make it so. Just because somebody says this, it may not be right. And you can use that idea even in science. And sometimes you'll hear this when you talk about ideas in space or ideas in astronomy. Well, there was this scientist, Albert Einstein, and he said that. And it's true. He said a lot of things, just like you've said a lot of things as well. But it doesn't matter what he has said. It's what does nature tell us? What is the data? What does the evidence tell us? And so he goes on to say, whatever is inconsistent with the facts, with our model, with our idea, no matter how much we like it, we can't just accept it blindly. And then the sentence that I underlined is what makes science so powerful. Science is not perfect. It's often misused. It's a tool. It's only a tool, but it's the best tool we have. Self-correcting, ever-changing, applicable to everything. With this tool, we vanquish the impossible. And what he's saying here is what we've been describing, that science is a process. It's a way of figuring things out. But because it's a way of figuring things out that we can test, it is so powerful because it tells us how things work. It allows us to have phones that are now more powerful than put the first 12 men on the moon. Notice I said men. If you're a young girl, you may want to ask yourself, how many girls have walked on the moon? And I'm sad to say that so far, not a single girl has walked on the moon. Now, here's the great thing. We're going to change that in less than 10 years. We're hoping in 5, but maybe it'll be 10. But by the time you guys finish high school, before you go to college, there will likely have been 2 women that have walked on the moon. And it's going to happen in the next 10 years. So it's exciting times. So why does science matter? So this is a video that I found on YouTube, and there's a lot of videos you can find on YouTube. And I encourage you to explore, but just be careful. You know, like everything on YouTube or on the internet, you can find good things and you can find not so good things. So if you're searching, you want to ask these questions, you know, maybe ask mom or dad to help you as you're doing your search on YouTube. But this is a short little video. It's about 2 minutes, 3 minutes, that uses words from my hero, that Carl Sagan guy. But instead of just words, what they've done now is put pictures of different places in the solar system. So you're going to see the gas giants like Jupiter and Saturn with those majestic rings. You're going to see Mars, a planet that we now have sent more spacecraft to than any other planet, well, besides Earth. We have orbiters, spacecraft going around Mars. We have rovers and robots on the surface. And of course, in about 10 days or so, we're going to send another huge SUV, car-sized rover that's going to go into another crater. And I think you guys have a really cool presentation about Mars and why we go to Mars and why we're going to Mars again. So I'm going to save that for that person. But I'm going to show you this video and just watch and listen.
For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species might be owed to a restless few drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, "I am tormented with an everlasting itch, forbidden seas." Maybe it's a little early. Maybe the time is not quite yet. But those other worlds, promising untold opportunities, beckon. Silently, they orbit the sun, waiting.
So I love that short little video. I show that to all my students whenever I can. Now, just to be clear, we haven't walked. We haven't sent humans to any other object other than the moon. And even to the moon, it's only been 12 men. That'll change, as I said. But in your lifetime, I'm convinced that not only we're going to have humans on the moon, we're going to have humans on Mars. And what an exciting world that's going to be when we have humans living on different bodies, different objects, trying to figure out how to do this. And the idea that Carl had was that we've grown up thinking that the only place we can live is on Earth. But in your lifetime, the answer to that is not going to be true. We're going to be living on many different places. Your generation, the kids your age around the world, aren't going to be bound to this pale blue dot, this blue marble, as he called it. They're going to be citizens of the solar system. So let's go back to Slido. I have one more question to ask you, and it's the same question I asked you before. Are you a scientist? So when we did that, when we asked this question before, we had half and half, if I remember correctly. Roughly half and half. Let's see, after a few pictures and some conversation, what happened. So we got about 30 people. Wow, looks like 9 and 10. We got 51 respondents. I'll give you another about 15 seconds because we want to get to some of your questions because you guys had some great questions you asked. Wow, look at that. So we'll stop it there at 65. We had over 90%. 90% said they're scientists. If you ask me a question on here, I will answer all of them. I'll just go in and type your response. So if we don't do it right now, don't worry, I will respond, I will reply, and you can ask mom or dad to help you to hear your response. But let's do these 3 questions that had a lot of votes, it looks like. Okay, why is there air in the Earth's atmosphere? Oh, that's a wonderful question. And as I told you at the beginning, and I'll tell you again, one of the best answers that you can have in science, you might think if you have a question and you don't know the answer, well, maybe I'm dumb. And that's not true. One of the best answers you can give in science is, I don't know, but we can try and figure it out. And so why the Earth has an atmosphere is a really interesting question. We now know that not every planet has an atmosphere. So you might know that Mercury is the first planet out from the sun, and it doesn't have an atmosphere. Well, it has a very thin one, but not anything like Earth. And then you might know the second planet out is Venus. And you might ask, well, okay, which is the hotter planet? And you might think it's Mercury because it's closest to the sun, but it's in fact Venus. And the reason why Venus is the hottest planet in the solar system is because it has a very thick atmosphere, just like Earth. So where do we get our atmosphere from? So it probably has a lot to do with the geology, how the rocks and the planet produces this. We have a lot of material that falls in when early in the solar system. How we make planets is kind of like how you make a snowball. If you played in the snow, or a snowman or snowwoman, you take something small, you roll it. If you're done with Play-Doh, you can do the same thing, right? You take a little bit of Play-Doh and you add more Play-Doh to it, you roll it up and it gets bigger and bigger. And that's how planets grow. And so we think the atmosphere comes about because of the different processes on the planet, volcanoes and geological processes, and of course, life. If you look at our atmosphere, a big part of it is oxygen, what allows us to breathe. And some 20% of the Earth's atmosphere is oxygen. And as you probably know, where does that oxygen come from? It comes from plants, right? It's the process called photosynthesis, a big fancy word, which means plants produce oxygen by taking in carbon dioxide, the thing we expel. Okay, and then great question, Aryan. And then Keon asks, what inspired you to become a scientist? That's a great question. I get that a lot. And I will say I've always wanted to be a scientist. What is true is I didn't know what that word meant. When I was your age, I didn't know what that word, what that word meant, nor what they did, which is why I was asking you this. What I knew, though, is I wanted to figure things out. I wanted to know why things are the way they are. And science was a way of being able to get at these answers and try and figure things out. And that's never changed. If you like solving jigsaw puzzles, you're a scientist. You're trying to put together all these clues and to figure out things the way they are. If you like reading books and trying to figure out what happens in a book before you get to it, you're a scientist because you're taking you're taking this information in and you're trying to figure something out before you get to get the answer in the back. Oh, these are great questions. I'm getting stuck answering into my head. All right, let me pick one. How is the universe so vast? So that is a great question. So when you think about the universe, again, think about these words that we use. So we live on Earth. Our Earth is a planet that goes around a star. Our star is called the sun. Our star, our sun, lives in a galaxy. And the name of our galaxy is called the Milky Way. And if you've been out at night, far away from cities where there aren't all the lights from our communities or houses or towns or large urban areas, you might have seen the Milky Way in the night sky. It's my background image. And our ancestors, the people that came before us, saw it, and they called it the Milky Way because it kind of looked like somebody had spilled milk across the sky. And when you see that Milky Way, remember that's our address. It's our location in the universe. So the universe then is this larger idea which has galaxies, maybe trillions of galaxies. And then inside of a galaxy, we have these stars. Our sun is an example. And around these stars, we have planets going around them. And our Earth is an example of that. How is the universe so vast? It just is. It just became so big. And so these questions about how was the universe born? We have ideas. You might have heard of the model. It's called the Big Bang. And you can explore that. You can ask questions about how did the universe grow? And that's a question in modern day astrophysics, which is taking the laws of physics, our ideas of physics, and applying it to the night sky. We can actually start putting this story together of how the universe changed with time, how matter, like atoms and molecules, the things we started talking about, formed, and then how those atoms and molecules form stars and planets and galaxies, and on at least one planet, you and me and life. We can figure that out.
Thank you so much, Shanil. That was really amazing. I think we all really enjoyed that talk. Well done to everyone who came in today and asking all these questions, interacting really well.